Today's daily code problem of the day is take gifts from the richest pile number 2558. For this problem, we're given an integer array called gifts, denoting the number of gifts in various piles. Every second, we do the following. We're going to choose a pile with the max number of gifts. If there's more than one pile with the max number of gifts, we're going to choose any of them. We will then leave behind the floor of the square root, meaning we're going to round down whatever the square root number is of the gifts in the pile. We will take the rest of the gifts. We're then going to return the number of gifts remaining after k seconds. So, if we look over here at example 1, we have gifts 25, 64, 9, 4, and 100, and we have 4 seconds to take as many gifts as possible. So, how are we going to do that? We're going to use a heap structure, which is kind of like a tree structure that is going to store our gifts in a relative path based off of how we want to sort them. So in this problem, we're going to use a max heap, meaning we're going to store each gift starting from the max going downwards. So we're going to have 100, and then 64, and then 25, and then 9, and then 4. And so that way we can go from the largest to the next largest, to the next largest, to the next largest, to the next largest, efficiently. So that's how we're going to approach this problem. We're going to use a maximum heap structure. So a maximum heap is like a priority queue, and we're going to use it to always pick the pile with the most gifts. So it's going to be a priority queue with the max always at the front. So we're going to initialize our max heap by adding all the pile values into our maximum heap, and this allows us to quickly access the largest pile at every step. We will then perform a k amount of operations, because we have a k amount of seconds, where we will pull the largest value, calculate the gifts to leave, meaning we're going to floor the square root of the current pile, and then we're going to add the remaining back to the heap. After our k seconds are up, we can calculate the sum by simply summing up the remaining values and returning it. So let's go ahead and jump into the actual code. First thing we want to do is take note that we want to return a long. Where's my mouse? We want to return a long because it is going to be a very big number, potentially. So we have to take that into consideration. First thing we're going to do is initiate our priority queue, or our maximum heap. So we're going to have a priority queue. This is always the hardest freaking thing to spell. It's going to store integers. And then we're going to call it our max heap, because that's the format we want. It's a new priority queue. And then when you're initializing your priority queue and you want it as a max heap, typically they are initialized as a minimum heap, but because we want a max heap, we're going to use collections.reverse order. So instead of a minimum heap, we are going to turn it into a maximum heap. Next thing we're going to do is add all of our values to our heap. That way we can store everything in the heap, so it's all sorted from max to min. So for each integer value in our gifts array, sorry for the construction on my house, we're going to have our max heap dot add each value. So we're adding each of the values to our maximum heap, so that way we can work on them in the future. After that is done, we can move on to the next step, which we are going to pull whatever the max is and then add back its square root. So for each integer I is equal to 0, as long as I is less than k, because we have a k amount of moves, and our max heap dot peak is greater than 1, because if it's not greater than 1, then we are not going to be able to square root it, I will increment. And we can't square root it because we only want whole numbers. Just make that clear. So we're going to go through each element we're going to go through each indice a k amount of times, as long as our max heap.peak, meaning the maximum value is always greater than 1. We're going to have our integer x be equal to the max heap.pull, whatever is current max, and that's the number we're going to be manipulating. So we can simply add back max heap dot add, and then we're going to convert it to an integer. This is how you round in Java. So we're going to automatically round down the math.square root of x. If you were using Python or something, you would typically do the function floor and then square root and then your number. But in Java, we are simply converting it back to an integer from a double, because when you square root it, it's going to be a double, and then adding it back to the heap. And that's it. So after that for loop, we are going to calculate our sum. So we're going to have our long sum, initialize that to 0 because the numbers could potentially be big, and for each integer value in max heap, we're going to sum plus equals the value. And then we can return our sum. So if we run this, this passes our test cases, and if we submit it, passes all of our solutions. Thank you. Follow for more daily Leetcode solutions.